Okay, now I'm looking at the section 3.4 handout, and the instructions for basically everything on this front page is to find all the zeros of the function, in other words, factor everything completely. Now the reason I put number 1 in here is the first thing you should always check is, can I just factor this polynomial? And the answer on number 1 is yes, I can factor this by grouping. So let's do that real quick. When I look at the first group of 2, I see I can pull out an x squared and be left with x plus 3. When I look at the second group of 2, I can pull out a negative 4 and I'll be left with, hey, how about that, x plus 3. Okay? So now, the x plus 3 is the thing that these two have in common. Okay, hang on, I gotta change batteries again. Okay, I'm back. So let's finish this factoring by grouping. We see now the things in the parentheses match. That is the common factor. That would be factored out to the front. I'd be left with x squared minus 4. And now I can complete the factoring by saying x minus 2 times x plus 2. Okay? And now I know that the zeros of this function are going to give me negative 3, positive 2, and negative 2. So I could list them over here. Negative 3, positive 2, and negative 2. Okay, so that was an easy one. Number 2 is not so easy. This time, what you have to do is you have to guess. Okay, they didn't give me a hint. I can't factor it by grouping. I have to guess what I think one of the factors might be, and then I check by dividing. So let me see, maybe I'll get lucky. Okay, and it will be luck because I don't remember the answer to this. How do you make a good guess? Well, there's actually a couple theorems in the book, but what I do is we're not going to get fancy. We're just going to look at the constant term. I see a 4, I try factors of 4. So I think I'm going to try 2 sounds familiar. So let's try. So my guess is that x minus 2 is a factor, and therefore in synthetic division I put a positive 2 in the box. I list my coefficients. Okay, and let's do this quickly. Wow, is that right? 1. Now I'm doubting myself. Negative 2, negative 4, negative 2. Yep, okay. So I must have a good memory. Okay, so that means I divided by, this means x equals 2 is a 0, which means that x minus 2 is a factor. And now what's left is x squared minus 2x minus 2. Okay? Then, can I factor this quadratic that's left? No, can't factor that. So, what we do, remember they just want us to find the zeros. And to find zeros, you take your factors and you set them equal to 0. This one's easy, x equals 2. We already knew that was a 0. But now I solve x squared minus 2x minus 2 equal to 0, and I use the quadratic formula to do it. Okay, so let's get out our scratch paper once again. Okay, and everyone has the quadratic formula memorized, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's plug in what we know. And remember, it's this equation that we're solving. So we're going to get 2 plus or minus the square root of 4 minus 4 times 1 times negative 2 all over 2a, which would just be 2. Okay, so let's see. 2, helps if you guys can see this, huh? Plus or minus the square root of 12 all over 2. Okay, simplify square root of 12. That would be 2 root 3 all over 2. Simplify this expression. I'm going to do it, please do it this way. Factor out a 2. And now this 2 is a factor and this 2 is a factor, and they're allowed to cancel. And there they are, 1 plus or minus the square root of 3. So let's put them down here on, where's my answer to number 2? So I'm going to make my cool brackets. 2 is a 0. 1 plus the square root of 3 is a 0. 1 minus the square root of 3 is a 0. And there they are. There are the zeros. Okay, now, number 3, we did that in class. I remember that was a group effort because we had a lot of guesses because 52 has a lot, not a lot, but several factors. So, I'll leave you guys to look at your notes for that one. Yeah, then number 4, I'd also like you to just go ahead and try that one on your own. It's the exact same problem. We want you to factor completely, okay? And in order to do that, first you want to see is there a greatest common factor? I have high hopes for 2. 2 might go into all of them. No, it doesn't go into 13. So you just start guessing, and I start guessing by looking at factors of 8, okay? You can make, now we'll just say factors of 8. So try 1 and 2 and 4 and 8, and then also positive and negative of all of those possibilities. All right, so now I'm going to go on to the next page, which is different stuff. Okay, now the second half of 3.4 is about building a polynomial or finding a polynomial, okay? And I'm going to do an easier example before we do the problems on the page. So what I'm going to do is kind of like a guessing game. I'm going to say to you, I'm thinking of a second degree polynomial. Okay, that means I need 2 factors, 2 linear factors. And I know what the answers are, or what the zeros are. I can tell you that x equals 3 is a 0, and x equals negative 5 is a 0. And now, and I can tell you the last thing is that, let's see, the leading coefficient is 1. Okay, we'll make it easy for this first time. Okay, well, if I know what the zeros are, remember from our list of equivalent statements, if x equals 3 is a 0, that means x minus 3 is one of the factors. If x equals negative 5 is a 0, that means x plus 5 is one of the factors. Okay? Remember I said this was a second degree polynomial, so I'm good. I've got 2 factors. Now, I multiply them out. Let's call it f of x. And I get x squared plus 2x minus 15. And then I check. That last piece of information I wrote up there was that the leading coefficient is 1. Is the leading coefficient 1? Yes, it is. So there it is. I have just created a polynomial that fits the criteria that I was thinking of. And this is how teachers make up problems, basically. We decide what we want the answer to be, and then we build a polynomial. Okay. Now, there's one more thing you need to know. We're not just dealing with real numbers here. We're also going to deal with complex numbers. So here, I'm asking the same question, but let's read it formally. It says, find an nth degree polynomial function with real coefficients satisfying the given conditions. Well, nth degree, n equals 3. Third degree polynomial is what I'm looking for. That means I need 3 factors, or 3 zeros. They tell me negative 1 is a 0. This complex number of negative 2 plus 3i is a 0. And then they tell me the leading coefficient is 1. Wait a minute, I need 3 zeros and they only gave me 2. Well, this brings us to the next thing you have to know. Anytime a complex number is a 0 of a polynomial, so is its conjugate. Every time. They always come in pairs. Okay? So that means I know that x equals negative 1 is a 0, x equals negative 2 plus 3i is a 0, and x equals negative 2 minus 3i is a 0. Oops, I don't need a parenthesis there, huh? Okay? And now I'm going to build my factors. So I would have a factor of x plus 1, a factor of x plus 2 minus 3i, and a factor of x plus 2 plus 3i. Okay, now, there are kind of short and fancy ways to multiply these 2 factors with the complex numbers in them. I just want to keep it basic and write them as I have them written and then multiply them out as if they each have 3 terms, because they do, okay? So, don't do anything else. Now, I'm going to pause and because that's going to take a little bit of time to multiply this out, right? And I'll come back with what you should get, and then also with the final answer.